Okay, let's start. Welcome to College Algebra Tropical Storm Imelda edition. I thought yesterday for sure y'all were going to get a day off, but fate has decided otherwise. And so we're together as usual today. There is a homework assignment that's due tonight, though, right? Okay, so it looks like today will be a good day to, given the weather, a good day to finish this one. Everyone I know has started it, or essentially everyone started it, because we worked on it in class last time, but there's still a lot left to be done on that one to bring the scores up where they should be. And then we have this other homework assignment, which is very similar. Maybe the problems here are slightly more difficult in part 2 than in part 1, but it's covering the same material. I pushed that back a little bit, so this is now due on Sunday. That is a Sunday, okay? So the 22nd is Sunday, all right? So you have so we don't often have homeworks due on the weekend, but in this time we will, okay? So please be aware of that. I'll try to remember to send a reminder to whatever email address you put in my math lab, okay? So I hope you're getting those. And then that quiz is not due till Monday, so we'll have another chance to look at that when we meet on Monday. And don't forget and I know you won't, but the test is on a week from today, and so that will still go forward as planned. Don't forget now the sample, right, is posted there in, this is the Blackboard, the class Blackboard page, right? So if you, so as I showed you before, right, if you go to sample tests, there it's posted, right? So be sure that you're, this weekend, if not before, you are, in addition to your homework, working on that sample test and your survival card, right? Your index card that you can bring with you to the exam of whatever information, right, you want to bring with you to the exam. That is a standard size index card, okay? So, you know, the index cards like we've been using here in class, right, that would work. It can be a standard size, so if it's slightly larger, that's okay also, but it has to be a standard size, right? It can't be one that you have created. If you don't have your name tag, your name tent, grab your name tent there for me, okay? Although we're getting more and more to know people, so name tents. Come on, this is just a routine part of the class, so. All right. Hang on just a second. We're going to do notes first, and then we've got I have a second sample test that we're going to take together in your groups today, okay? So it's test practice in a little bit different format, though. I'll explain to you what the format is when we get to that. But I want to talk first so we can finish. I want to make sure we're pretty far into the notes. Arthur's back, so he can get that back. There's the, okay, this goes for Emiliano, so just look at Emiliano at some point. Okay, right here. But I want to make sure we're pretty far into the notes. All right, we keep getting delayed on the notes. Do y'all have questions to start with here? Okay, that you want to ask? So remember that the homework, right, is coming up. So, and we're not going to do homework in class today. So that'll be your responsibility to finish that after class, right before the midnight due date. Okay. Okay, all right, good. All right. But any questions about that, homeworks? Okay, we're gonna pick up right where we left off in the notes last time, and finish these notes, and maybe start a new set of notes before we get to our activity a little bit later here. So last time we were talking about finding domains of and ranges, but primarily domains of functions represented in different forms, right? Do you all recall our so we stressed this quite a bit, right? Do you recall our three main ways of representing functions or expressing functions? What three main systems do we use as function rules? Table, right? Graphs, and what's the third one? What? Equations, or I would say formula, okay, right? But that's going to be in the as an equation, right? So here's an example of a. So we're going to talk today about finding domains and a little bit about ranges. Although I mentioned last time that's a harder problem, finding ranges of functions for functions expressed in these different forms. Okay. So last time we looked at an example of a function represented as a formula. Here's a formula, right? Okay, and we wrote down what its domain was, right? And we just decided last time that the domain was going to be all real numbers, okay? And really, the basic reason for that is we didn't have any idea about how this function is being used in practice, so we don't know what the quantity, what the input quantity x represents for this function. We don't know if it's weight or time or distance. So we don't have any information like that for us to restrict the domain. So without information like that, we'll just assume that the domain is as large as it can be, and that means basically what numbers can you substitute into that formula and carry out the arithmetic. And we decided, well, there's no limitations in that formula, right? We can square any number. We may have to have a calculator to help us, but we can square any number, and we can subtract, right, with any values. So that means by default that the domain will be really big here, all real numbers. And we'll encounter lots of functions whose domain is all real numbers, but there will be exceptions, right? And so it's the exceptions that we want to concentrate on. So let's look at this also simple function formula, right? Just 5 over x minus 2, correct? Okay. And when you start evaluating that, function for different inputs, then you can see what goes wrong. Sometimes, all right? So if we try to evaluate h of 0, that's pretty simple. You're just going to get 5 times 0 minus 2, correct? Which is minus 5 halves. So there's no problem there, okay? The input 0 results in an output of minus 5 halves, all right? So nothing exciting about that. And but, however, when you try to evaluate h of 2, okay, then you'll notice that things go slightly astray, right? Because when we plug 2 in for x, we end up here with 5 divided by 0, and you cannot divide by 0, right, in arithmetic. So this output is undefined, okay, or doesn't exist, or there are different ways of expressing that idea that you can't divide 5 by 0, okay? So what that tells us immediately here is that this function's domain is not going to be all real numbers, okay? Because when we try to use 2 as input, we end up with this problem, right? You cannot get a matching output. The matching output is not defined, right? So here's a function whose domain is not going to be all real numbers. But the 2 is the only really problematic input for this function, okay? Because it causes you to divide by 0. Any other input value used for x, you'll be able to carry out the arithmetic in the function formula. Like, for instance, when we plugged 0 in for x, right, we were able to carry out that arithmetic, minus 5 divided by 2, okay? And so with this domain, with this function, the only restriction that we have on the domain is it cannot include the number 2, okay? It cannot include the number 2. So there are ways of writing down that set, okay, of all real numbers except the number 2. But for the time being, we're just going to write this out in words, okay? So we're not going to learn yet here any other fancy mechanisms for writing out this set. I'm just going to say the domain here is all real numbers except 2, okay? So I'm just going to spell it out in words. You could, well, like I said, there are other ways of expressing this domain. You could also write x not equal to 2, okay? That would be another way of getting the idea across, right, that any other value for x will work as domain for this, as input to this function, but we cannot use the number 2, okay? So, well, that's a pretty easy example to understand, right? But it does illustrate one of the important ideas when we're trying to find domains of functions that are written as formulas like this, okay? If you have an input that's going to cause you to divide by 0, then obviously you must throw out of the domain, okay? So, and that's an issue that comes up frequently with functions that are expressed as formulas. We'll try to use plug numbers into the formula. We'll try to use input values that are causing us to divide by 0, and of course we cannot do that. So we have to make sure that we take those numbers out of the domain. But otherwise, so far as we know, any other number we can use as input for this function. So domain, all real numbers except 2. Notice again here, I'm not really talking about the range, okay, because that is a trickier problem. All right. Let's look at the another issue, right, that, oh, well, no, let's not look at another issue. Let's take a slightly different example, okay? Here I just took the reciprocal of that formula, right? Previously I had 5 divided by x minus 2, but now so in this formula I have instead x minus 2 divided by 5, okay? So if we evaluate f of 2, that's easy to evaluate there, right? Okay. We don't run into this problem any longer of the matching output not being defined, okay? Because here, when you try to evaluate f of 2, you get 2 minus 2 divided by 5. That's 0 over 5. That's not undefined, okay? Right? That is a number. 0 divided by 5 is 0, okay? So you can divide into 0, but you cannot divide by 0. When you divide into 0, you just get 0, right? So for this function, 2 is part of the domain, okay? We don't have to exclude it from the domain. In fact, the domain for this function will be all real numbers, okay? Because in this function, just think about the arithmetic that's going to be involved in this formula. You're subtracting 2, right? It's easy to subtract 2 from a number. And you're also dividing by 5. You can divide any number by 5, okay? Dividing by 5 doesn't have the same issues as we have when we're dividing by 0, right? Okay. So for this function, there's really not going to be any restrictions on the domain. So again, we can just write here, like we did in the first example, domain here is going to be all real numbers. I wanted to show you this evaluation too. It really doesn't have to do with the domain, okay? But frequently when we're using functions, we will want to evaluate the function at numbers, of course, right? But also sometimes at inputs that involve variables, all right? So here we're evaluating the function f at the input 3x that involves that variable x, all right? Sometimes this confuses students because x is also the input variable in the function formula, right? But don't let this evaluation confuse you, all right? Just because you're seeing x in 2 places here, all right? To evaluate f of 3x, you're just going to take that quantity 3x and you're going to substitute it for x in the function formula, all right? So everywhere you see x, you're going to replace it with 3x in the function formula. So I get 3x minus 2 over 5, and that's it, okay? that's as far as you can simplify by hand. Okay, so there is your output there, your matching output, just 3x minus 2. Is Amber here? Amber's not here. Okay, Amber's the one who's been signing in the wrong place. All right, so I was going to warn Amber what her correct spot was. So refer back to again what you where you signed on the first day, right? Okay, because that's where you've got to be signing. Amber's been signing in the wrong place occasionally, and that's been throwing other people off. All right. Okay. So f of 3x is just going to be 3x minus 2 over 5. All right. That's it. Okay. So that's all you're expected to write down there. Is that expression. Okay, let me get to the example that I thought was that I was talking about a moment ago. Okay, this formula now illustrates another issue that comes up when you're evaluating functions. Okay, let's try evaluating this this function s. Okay. So there's finally a function there not named f, right? This function is named s, and the input variable here is t, okay? Let's try evaluating this for some inputs, and it's a very simple function formula, right? So it's not hard to evaluate s at particular inputs. S of 6, for instance, is going to be just the square root of 6 minus 2, so that's the square root of 4, which is 2, right? Okay. S of 4 is going to be the square root of 4 minus 2, which is square root of 2. That is a number, okay? So square root of 2 is a number, right? Okay. That value is not undefined. There is a number on the number line that is the square root of 2. It's just not going to be a whole number, okay, because 2 is not a perfect square, all right? If you ask your calculator what the square root of 2 is, your calculator will say it's about 1.414, but that's only a decimal approximation. There's actually infinitely many digits in the decimal expansion of square root of 2. So this decimal expansion will continue forever, okay? But to 3 decimal places, I think it's 1.414, okay? But S of 2 does exist, all right? So S of 4 does exist. So that means 4 is going to be in the domain of your function, all right? That is part of the domain. What about S of 2? That's easy, of course. That's going to be square root of 2 minus 2, so that's square root of 0, and that 0 is a perfect square, so square root of 0 simplifies to just 0, all right? So far there, right? So good, no issues. But when you try to evaluate S of 0, then you run into problems, right? Okay, because we get square root of 0 minus 2, and that is the square root of negative 2, and this is not a real number, okay? The square root of minus 2 is not going to be a real number, all right? So there is no real number, so that when you square it, you get negative 2, okay? So that means square root of minus 2, not a real number. Later on, we're going to learn how to actually think about square root of minus 2, even though it's not a real number. We're going to learn how to actually use this value, make use of this quantity, square root of minus 2, but it's not going to be part of the real number line. So there's no location, for instance, on the x-axis that corresponds to square root of minus 2, all right? So for the time being, at least, we would have to say 0 is not in the domain of this function, because I cannot carry out this arithmetic. I cannot evaluate square root of minus 2, okay? It does not come out as a real number. It's not quite the same as dividing by 0, okay, which doesn't exist, but we still have issues with square root of minus 2. So for that reason, we're going to say 0 is not in the domain of this 0 is not in the domain of this function. And actually, there are going to be a lot of other numbers not in the domain of this function. For instance, if you tried evaluating s of minus 1, right, you get exactly the same problem. You get square root of minus 1 minus 2, but that's square root of minus 3. And again, see, this is not a real number. So it's not just 0 that's the bad value here. There are actually lots of numbers that we cannot include in the domain of this function s. All right, so that creates a little bit of a dilemma for us, right? How do we actually figure out what the correct domain is for the function s? All right, because we can sort of already see here, right, that lots of values not going to be in the domain of this function s. All right, here's what you can do. All right. See, the problem we have with this formula is we've got this square root in it, right? And we know we can't take square roots of negative numbers. So whatever we plug in for t, we want to make sure that this quantity under the radical, that's called the radicand, by the way, the quantity under the radical, we want to make sure that that turns out to not be negative, right? We don't want that to turn out negative like it does in this case or like it does in this case. So let's write that down. Whatever I plug in for t, I want to make sure that it comes out to be bigger than or equal to 0, right? Okay? Because if it comes out negative, I'm going to have an issue. Exactly the same problem that I had in these two cases. So let's just say that. I have to make sure that t minus 2 is greater than or equal to 0. Well, let's see. If t minus 2 is greater than or equal to 0, then how big does t have to be? Can y'all tell me that? How big does t have to be if t minus 2 has to be bigger than or equal to 0? At least how big does t have to be? What? 2, yeah, exactly right, okay? Because you're subtracting 2, correct? Okay? So you have to make sure that whatever value you plug in for t, right, you have to make sure that it's bigger than or equal to 2. Otherwise, when you subtract 2, you're going to end up with a negative quantity, correct? That, then, is going to be your domain, all right? That's the domain. Numbers bigger than or equal to 2, okay? That's why 0 didn't work, right, as part of the domain, because it's not bigger than or equal to 2. That's why minus 1 doesn't work, because it's not bigger than or equal to 2 either. Notice 1 wouldn't work either, right, okay? 1 wouldn't work in the domain because 1 is not bigger than or equal to 2. So the only domain for this function, exactly those numbers bigger than or equal to 2. There is the domain, okay? So let's write that. So there's our domain. Just say, numbers bigger than or equal to 2, okay? So you can write that in an equality like this, or you can actually write it out in words if you want to. You could say all real numbers greater than or equal to 2, okay? That's kind of a lot to write out in words. That's why it's nice to express it this way, but you always have this option. So all real numbers greater than, make sure you say equal to, greater than or equal to 2. So that's a big set, okay? There are lots of numbers greater than or equal to 2, but that's not all numbers, right? Okay, because there are lots of numbers that are not bigger than or equal to 2, right? Okay, so you have a really big restriction on your domain here. All right, so actually we've seen now already the two cases that we really have to worry about when we are trying to determine the domain of a function from the formula. So I've written down here for you just a little guideline here, okay? So here are the instructions, all right, to follow if you're trying to find the domain of a function represented by a formula. This is from a formula, not a graph or a table, but from a formula, okay? All right, first, if you have a fraction in your formula, okay, like in this case, right, okay, there we have a fraction in the formula, all right, then you want to do the following. Take the denominator of that fraction and set it to 0. Set that denominator, the bottom of the fraction, to 0 and solve. Whatever the solutions are, you're going to throw those out of your domain, okay? So your domain will be all real numbers except for whatever these solutions are, okay? The other case is if you have a radical in your formula, in particular square root, okay? That's usually the radical that you'll see most frequently. If that's the case, take the radicand, that's the quantity under the radical, and set it greater than or equal to 0, and then see if you can solve that inequality. Okay? And whatever the solution to that inequality is, that's going to be the domain of your function. Those are really just the two rules you have to follow. If you don't have any denominators and you don't have any roots, then your domain by default will be all real numbers. Unless, okay, you have some other information that you could use to restrict your domain. What other information could you have? Well, see, you might know how the function is used in practice, and you might know that the input quantity for a function is, for instance, weight. Now, if input quantity is weight, then that's also going to restrict your domain, right, Ben? Because what numbers can you not use for weight? Negative, right. So you wouldn't use negative numbers, right? Okay. So those would not be in your domain. If your input quantity is distance, same thing, right? You wouldn't use, we usually don't measure distance in negative amounts, okay? So you wouldn't include negative numbers in your domain in that case, okay? All right. So look, these two rules now you're going to have to remember, okay? So they're in the notes, so write those down, right, okay, or make a copy of these notes, right, print a copy of these notes, right, okay, because you're going to have to use these rules, well, in particular on test number 1. Let's use them right here on this example, though, okay. So here I want to find the domain of this function, 4x over x squared minus x minus 2, okay. So according to my little recipe there, on the right-hand side, what am I going to do? Do what? Set the denominator to 0. That's right. Okay. So, Kevin, what does that look like when I set that to 0? Can you just read that off to me? Yeah. Yeah. When I set the denominator to 0, I'm going to get an equation. Okay. Yeah, that's what I meant, right, okay. X squared minus x minus 2 equals 0, right, okay. And now we have to solve that equation. Wow, okay. That's a little bit harder equation to solve than some of the other equations that we've seen in class, all right. So how do we solve that equation? We're going to spend a lot of time actually talking about solving equations like this one. What's tricky about this equation is that the unknown is squared, okay? So that makes the equation a little bit more difficult to solve. But I'm going to show you just the standard technique that you can use to solve an equation like this one. Take the left-hand side and factor it. So see if you can factor the left-hand side. X squared minus x minus 2. You won't always be able to do that, okay? But try, okay? So let's see if we can factor x squared minus x minus 2. You know what I mean by factoring, right? I mean you're going to write that as a product, okay? So write down two sets of parentheses there, and then we want to fill in those parentheses, right? So that when we multiply the parentheses back together, we'll get x squared minus x minus 2. Can y'all tell me what to fill into the parentheses? What's going to go here and here? Got to be x, right? Because when you multiply these together, you have to get x squared, right? So it's pretty obvious that here and here, you're going to have x and x, right? Because that's the only way in the products you'll get x squared. Now, here and here, you're going to have to put numbers in, right? And the product of those two numbers has to be 2. There's not many ways of writing 2 as a product because 2 is a prime number. So what has to go here and here? Yeah, well, 1's got to go in one of the places, right? And 2's got to go in the other one because that's the only way you can express 2 as a product, right, is 1 times 2. The only other question is how do we fill in the signs here? So someone already made a suggestion. What did y'all suggest for me? Minus 1? Minus and plus? Let's check that. Think the other way around? Well, let's check. Okay, so x times x is x squared. X times 2 is 2x. Minus 1 times x is minus x. And minus 1 times 2 is minus 2, right? So we almost have it because we have the x squared and the minus 2 just like we want. But how do these two middle terms add up, unfortunately? Yeah, you have 2x minus x, but that's plus x, right? Okay, and we want minus x. So how can we fix that? Do what? Change the signs, that's right. So make this one plus, correct, and then change this one to minus, all right? And that'll make this minus 2x plus x when you take the product. And now minus 2x is minus x. So there's the correct, there it is, there's the correct factorization. Now, remember that factorization was just part of solving the equation, so we've not finished solving the equation yet, right? But we're right on the cusp of solving that equation. Here's why, okay? Here you have a product. See, these things are multiplied together. You have a product that equals 0. In real number arithmetic, okay, in real number arithmetic, the only way you multiply two things together and get 0 is if one of the two quantities, or maybe both, but at least one of the quantities has to be 0. You cannot multiply two numbers together and get 0 unless one of the numbers is 0, okay? This is called the zero factor theorem, all right? And that's a very important property of real numbers. So see, what I know here is x plus 1 is equal to 0, or x minus 2 is equal to 0. Now you have two equations to solve, so in a way we've made our life worse, right? We started with one equation and now we're down to two. But these are very easy to solve, right? Okay, what's the solution here? Negative 1, right, okay? So x equals minus 1, and then the other solution is just x equals 2. All right. So there we've solved the equation. Notice we came up with two solutions there, negative 1 and 2. Now what do we do with those two solutions? I forgot what we were doing, right? Okay, but you don't want to do this on your homework or the test. You don't want to forget what we were doing. We found those two solutions because what are we gonna do with them? What does our rule say? See, we solved. Now what is the last step there? Yeah, we're going to exclude those solutions from our domain, okay? So our domain is going to be all real numbers except what? That's it, right, okay? So there you've got it. There's what the domain is. So for this function, you are free to use any input value you want for x, but these two, okay, those are the forbidden inputs, all right? So you have a really big domain there. It's almost all real numbers, except you're just missing those two possibilities, right? Okay. All right, so that's if you have a fraction in your function formula. Remember, the other case that you have to think about now is, I don't have another example of this, but it'll come up in the homework. The other situation you have to think about, right, is if you have a radical. In particular, it's got to be an even root. So that would be square root or fourth root or sixth root, but you rarely will see fourth roots or sixth roots. In fact, you'll almost never see sixth roots, okay? That's really unusual. You might see fourth roots from time to time, but mostly square roots, okay? So if you have a square root in your function formula, take what's under the square root, set it greater than or equal to 0, and solve that inequality. You don't exclude those numbers, though. Whatever the solution to that inequality is, that is the domain, the total domain for the function, okay? It's just those two situations. If you're looking for a domain of a function represented by a formula. Now, however, we don't always represent functions by formulas. So what if we have a graph? Well, that's really easier, okay? So here's one of the nice things about graphs. With graphs, So these, I didn't blow these up very well, so they came out a little bit fuzzy, but you can read them, okay? All right. One of the nice things about graphs is it really makes domains and ranges a lot easier to write down, okay? Because you can just see from the graph what the domain and even the range is going to be, okay? So with a graph, we don't have to skip around that question of what's the range. We can actually see that from the graph. Let's look at these graphs then and write down actually both the domain and the range. So what about for that first graph? Okay, there's a nice semicircle. That is a function. That is a function because each input is going to give you just one output. You're not going to have multiple outputs for the same input. So that's definitely a function. But what numbers can we use as inputs, right? What's the domain here? Kind of obvious, right? Where does it start at? -3, sure, right, because that's where the graph starts, right? So we have to use x values bigger than or equal to -3, but we can only go up to what? +3, sure, right, okay, yeah. You cannot evaluate that function at numbers bigger than 3, right? No way to do that. So you can't calculate f of, this is 4, right? You couldn't try to calculate f of 4 because there's no way to read the graph, right, when x is equal to 4, okay? Or you couldn't try to evaluate f of -4 because there's no way to read the graph when the input is -4. Now, on the other hand, what about the range? So what outputs, what y values can you get for this function? Y values now, okay? Those are that's the range. So what's the smallest y value there you're going to get? 0, right, okay. Arthur, why'd you say 0? What now? That's right, okay. That's the lowest that the graph goes along the y-axis, right, at 0, right? So the lowest output you're going to get is 0. What's the highest one there, Arthur? It's 3, right, okay. Count up there. 1, 2, 3. Right there, right? There's the highest one we can get, okay? So the range there, we can also, for the graph, we can also write that one down, okay? So, again, for formulas, it's hard to write down the range, but for graphs, it's much easier, usually easier, okay? What about for this function? So that type of curve is called a parabola. So this one's a little bit mysterious, right? Okay, because of the arrows there on the left and the right. Okay. Of course, when you're drawing a graph, right, you cannot draw the entire x-axis, right? Because the x-axis is a number line and it extends, to -infinity on the left and +infinity on the right. So you can't draw all of that, correct? So you only have to draw a piece of the x-axis. That's called the x window, remember? And when you're, of course, also for the y-axis, right, you can only draw a piece of the y-axis. That's called the y window when you're making the graph, okay? All right, so that being the case, though, what we've indicated with these arrows here is the curve doesn't stop at the graphing window, all right? So this curve is going to continue both on the left and the right, okay? And, of course, we really can't see how it continues, but we have to assume that whoever drew this has been friendly to us, and the graph is going to continue in sort of the same pattern, right? Okay? In the same shape on the left and the right, right? So if that's true, if that really is how the graph looks, it's going to continue like this on the left, going to continue like this on the right, then what would our domain be? Which we can also say as what, Kevin? All real numbers, right? Okay. So domain there we can write down as all real numbers. So we're not 100% sure of that, right? Okay. But that's sort of what whoever drew this picture, right? Okay, the artist who drew this graph, right? That's sort of what they're indicating to us, okay, from the way they drew the picture. What about the range, on the other hand? That's right, okay, so the range is going to start way down here at negative infinity, right? But it's going to max out right there at 2, right? So you can say, you can write this down in a lot of ways, all right? So we could say y, remember the output values are y here, you could say y is anything less than or equal to 2, okay? Anything less than or equal to 2. Or you could just spell that out in words, all right? So you could say all real numbers less than or equal to 2. Sometimes in your homework, the my math lab will put negative infinity or positive infinity into the inequalities when you're writing down domain and range, okay? You really don't need to do that, so if you just wrote y less than or equal to 2, that would mean y going all the way down to negative infinity. But sometimes my math lab will include both sides of this inequality, okay, in their answers. All right, so here's a half line, all right, okay. Just half of a straight line. So what would we say is the domain there? So where does that graph start at along the x-axis? -1, right, okay? So clearly our domain is going to start there at, -1, and then it looks like the graph is going to continue here, right? The graph is going to continue there on the right-hand side. So that being the case, it looks like the domain extends all the way out to positive infinity on the x-axis. Now, the reason the open circle has been put there, that's put there for a reason, okay? What that shows you is, although your domain starts at -1, -1 itself is not part of the domain. -1 is not part of the domain. So when you're writing down the domain, you would say x greater than -1, okay? Numbers bigger than -1, but not greater than or equal to -1, all right? So the open and closed dot is sometimes a convention that we use when we're making graphs to indicate where a graph stops and starts, right, and whether the boundary value is part of the graph or not. So this point, although the graph stops at this point, that point is not included in the graph, okay? So -1 not really in the domain. What about the range? So what would our y values be here? Greater than 2? I don't think greater than 2, right? Because this line is going down, right? Less than 2, right, okay. So the range there are y values less than 2, correct? Okay. Again, not including 2, okay? Not including 2 because this point is not actually on the graph. Okay, it's a boundary for the graph, but it's not actually part of the graph. So again, you could say this in words, right? This is all real numbers less than 2. This is all real numbers greater than -1. Or you can just write it down as this inequality. It's understood what that means, okay? What about for our last example here? So here we have kind of half of a parabola, right? Or 3/4 of a parabola there maybe. This is a parabola, but that type of shape there, that U-shaped curve, is called a parabola, but we've cut off a piece of it, right? The piece there that's on the right. So what about the domain here? Where does the domain start? Domain. So remember, domain is x values minus infinity. That's right, okay? Because this graph, this parabola, is continuing to the left, right? So the domain starts at minus infinity and continues until where? 2, right, okay? So stops there at 2. So again, the way to write that, easy way to write that down with an inequality is just say x is numbers less than 2, okay? I really shouldn't put an equal mark there, but I'm cheating a little bit. What about for the range now? Be careful about the range, all right? So what y values can you get as output from this function? Now, it's very tempting to say that the range starts at minus infinity and goes up to 3. I'm sorry, okay. It's very tempting to say it starts at minus infinity, and then you want to look at this point, and you'll say it stops at minus 1. But that's not where the range stops at, right? Okay? Because the curve actually extends all the way up to 3 on the y-axis. So actually the range is minus infinity to 3, okay? It's not minus infinity to minus 1, even though that point, right, the y-coordinate of that point is minus 1. So be careful about that when you're reading ranges from graphs, okay? Make sure you look at the whole extent of the graph along the y-axis, right? Don't just concentrate on the right point on the graph or the left point on the graph. Here's now where graphs are a little bit not helpful. So the range is y values less than, goes up to 3, right? But you really can't tell, does it go all the way up to 3, or does it stop a little bit less than 3, or... Yeah, so it's hard to know, okay? So if you put less than or equal to, that's fine, okay? If you put less than, that would also be correct, all right? You just cannot read it accurately, the graph accurately enough to know for sure if 3 is part of that range or not, okay? That's one of the disadvantages to graphs, all right? But we've talked about this before. Sometimes it's hard to read, or frequently, it's hard to read graphs accurately, okay? So you can't get perfect accuracy when you're working with functions that are represented by graphs. All right, I have a couple more questions there. All right. So I said now it's kind of tricky, right? When you have a function expressed as a formula, it's hard to find the range, okay? So not so difficult when you're looking at a graph, right? Because we just practiced it with several examples, right? But if you have a function represented by a formula, it's hard to know what the whole range is. But sometimes we can answer a simpler question. If someone asks you just, is a particular number in the range, not what is the entire range, not what's the whole range set, but is just a given number, is that in the range? That question is a little bit easier, and it's easier to answer. So here's an example of that. For this function, that was in one of the earlier examples, 4x over x squared minus x minus 2, we want to know, is minus 2 in the, not the domain, okay, but is minus 2 in the range, all right? So that, obviously that's just a yes or no question, right? But I don't have a graph, right? Okay, so how do I, don't have the graph there. I guess we can make a graph of that function and look at the graph, but without making a graph and looking at the graph, how can we answer that question? Plug it in where? For y, that's right. Yeah, so Juliana, you're exactly right, okay? If this number is going to be an output, right, that means we have to get it as a y value for some input, correct? Okay, so what I'm going to do is just take the minus 2, and in my formula, I'm going to plug it in for, not x, right? Okay, because that would put minus 2 in the domain. Instead, I'm going to plug it in for y, right? Okay, because y is what corresponds to the range. So we end up with this equation, minus 2 is equal to 4x over x squared minus x minus 2. Wow. And now I have to see if I can solve that equation. Yuck. All right. So kind of a yucky equation there to try to solve. Okay. Well, but that's the task that we're stuck with. Okay. So let's see if we can do this. All right. So let's think back to techniques we know for solving equations. Okay, because y'all solve lots of equations, but it's easy to get rusty with solving equations. All right. Here's the first thing I would do, okay? This is my advice to you as well when you're solving equations. Equations with fractions in them are usually messy, okay? So I would like to get rid of the fraction, okay? First thing, want to get rid of the fraction. How can you get rid of this fraction from this equation? I multiply, that's right. By what, Emiliano? That's right. So I'll multiply both sides by x squared minus x minus 2. Make sure you multiply both sides, okay? So I get x squared minus x minus 2, and I'm going to multiply here x squared minus x minus 2 times the minus 2, okay? Right? Now, great things happen on the right-hand side. The denominator cancels just like I wanted. So I get 4x is equal to, and now let's expand this product. So minus 2 times x squared is minus 2x squared, and then minus 2 times minus x is plus 2x, and then minus 2 times minus 2 is plus 4, okay? Now I'm looking at equation, and I just saw an example of earlier. Here's an equation where don't forget the 4x is here, right? Here's an equation where the unknown is squared, okay? The unknown is squared. We just practiced that a moment ago, right? Okay? What was our trick to solving that equation a moment ago where the unknown is squared? We did what? Was the F word there? Factor, right, okay? Factoring. But before you factor, you've got to set this thing to 0, okay? So you've got to get this equation set to 0. The factoring will not help you if one side of the equation is not 0. So what I'm going to do here is I'm going to move everything on the left-hand side. You could go the other direction as well, but I'm going to move everything on the left-hand side over to the right. So I'll have 0 is equal to 4x, and now when you move these terms, right, when you move these terms to the right-hand side, the signs are going to change. So you'll have plus 2x squared minus 2x minus 4, right? Be sure you change the signs. So that becomes plus, this becomes minus, this becomes minus, right? And let's see, are there any like terms here I can add together now? Yeah, the x is correct. So I end up here with 0 is equal to 2x squared, and then plus 2x, and then minus 2. And now I'm going to try to, is that right? Minus 4, okay. All right, now I'm going to try to factor, okay. See, I've got it set to 0. That was step 1, got it set to 0. Now I'm going to try to factor. Again, the reason that we're trying to factor is because we have the unknown here squared, okay? If you didn't have the unknown squared, you wouldn't have to do this. All right, now let's see if we can factor. This is, I know where I can start factoring this because there's a number you can factor from all of these terms. What number can you factor out of all of those terms? 2. So I'm going to start by taking out a 2. That's not completely factored, but I'll start by taking out a 2, okay? So take out the 2. That leaves you with 2 times x squared plus x minus 2, right? Because when you factor 2 from minus 4, that's minus 2. Now we're going to try to factor this. I think y'all can do that for me, though. Can y'all factor x squared plus x minus 2? It's going to be x and x, isn't it? Right? See, I'm factoring this part, right? So what goes after the x? So what numbers do I fill in here? X minus 1 and what? Plus 2. Yay! Right, okay. Great, right, okay. X minus 1 times x plus 2, right? Let's see, is that right? X times x is x squared. Of course, minus 1 times 2 is negative 2. And then in the middle, you'll have x times 2 is 2x. And minus 1 times x is minus x. So you get 2x minus x. That's x, right? Yay! So there it is, factored. So it does factor. That's great. Okay. If it didn't factor, I'd have to resort to Plan B here. But this does factor, and so that tells me, right? I have this product. I have a product here that equals 0. The only way a product can equal 0 is if one of the factors is 0. Okay. So it's possible that 2 is 0, but I don't think that's true, right? So just wipe that out. Or x minus 1 can be 0, or x plus 2 can be 0, right? This means x is equal to 1, and this means x is equal to minus 2. Wow, okay. Wow, what did I... All right, now, remember, this had nothing to do with the domain, right? We were answering a question about range, all right? My God, what have I just discovered now, okay? So I set the y to minus 2, solve the equation for x. So what have I just learned? Well, I've learned the solutions to the equation, but what are those solutions to that equation telling me, okay? No, because this is not domain, all right, okay? Yeah, I was trying to decide if this number is in the range, okay? So minus 2 is in the range. Yes. Why? Because this input and this input, when you plug them into the function, guess what? You will get an output of what? Plug this and this into the function, you will get an output of what? Negative 2, that's right, okay? So what I discovered here, Leslie, is these two inputs for this function, these two inputs give you an output of minus 2. That means minus 2 is in the range, you see, okay? These two x values have a matching y value of minus 2. So minus 2 is definitely in the range. What's the rest of the range? I don't know, okay? But it definitely includes minus 2, because we discovered these two inputs that give you the matching output of minus 2. All right, so wow, we just answered this question. How do we determine if a number is in the range of a function represented by a formula? How do we determine that? What do we do? What did we just do here? We plugged it in for what? Y. And then what did we do? No, we plugged it in for y, and then that gave us an equation. And what did we do with the equation? What did we do with that equation? What? Well, yeah, you're describing the process, but that process was part of doing what with the equation? What do we do with equations in general? No, yeah. When I give you an equation, what's the first thing you think to do with it? solve it right, okay? So we plugged our number, our questionable value right in for y. That gave us an equation, and then we solved the equation. So there's the answer to this question, right? How do you find if a number's in the range of a function? Represented by a formula, plug it in for y, or the output variable, and solve the resulting equation. If you can solve that equation, the answer is yes, it's in the range. If you cannot solve that equation, then that means, well, let me put that more carefully. If that equation has no solutions, that means the number's not in the range, okay? No way to find an input that will give you that matching output. All right, we're going to stop there, okay? And now we're going to do something. We're going to practice a little bit for the test, but we're going to practice together